So here's a man, he walks that way, and then coming back, he's on a trolley. Okay, and that's coming a little bit faster. I don't know why I did that, but it's coming back this way. It's coming back at 20 miles an hour. Okay, so I know that the whole thing took 3 hours. The time is 3 hours. And how far can you walk? What's the question? How far can we walk into the country and right back? Okay, so how far did he walk? So what was the distance traveled when he walked? And I guess as opposed to the distance traveled. The distance is the same, but one he walked. No, wait a second. How far can he walk into the countryside and right back on the trolley? He must be home. He must be back home 3 hours from the time he started. Okay. All right. So how far did he go before he had to turn around and come back? All right. So man, trolley. Oops. Rate. Oh, wait, I make this a big. All right. Rate time. All right, guys. So the rate that the man travels for the trolley goes at a speed of 20. I know the total time is going to be 3. Let me write distance here. So the time the man spent walking was t. So obviously the time on the trolley would be 3 minus t. So the distance here, we multiply, remember, 4 times t is 4t, distributed property is 60 minus 20t. So one thing we do know about their distance, we don't know what the distance is, the actual distance, what 10 miles, 5 miles, whatever, but I know that the distance equal each other. So the distance he walked and the distance traveled on the trolley is the same. So that's how I set up my equation. So minus 20t, there's variables on both sides. Let's get rid of one. And I, just because I like doing this, I'm going to get rid of the smaller one. In this case, the smaller one is minus 20t. So I do plus 20t on both sides. 24t equals 60, because that goes away. Divide both sides by 24. And t equals 60 over 24. Now, I'm going to leave that as a fraction, improper fraction, but if you want to change it to an improper fraction, mixed number, it'd be 2 and something, right? 2, 48, 12, 2.5 hours. Okay, so actually we can change this to 2.5 or 2.5 hours. Actually, that's probably better. But, so that's the time. So that, going back here, the man spends 2.5 hours. So what is this? T is 2.5. So the time spent on the walking was 2.5 hours, which means the time on the trolley is only 0.5 of an hour. Okay. If you want to take this extra step, and just to double check, the distance the men travel was 4 times t, or 4 times 2.5. Okay, so I'm going to call that man. And that's equal to, 10 miles. Now the trolley also has to travel. So the trolley here is 60 minus 20t. 60 minus 20 times 2.5, right? Decimal wise. 60 minus, and then 2.5 is 50. And guess what? So the man walked for 10 miles. Okay, that makes sense. 2.5 hours, 10 miles, yeah. And then the trolley also, of course, traveled 10 miles. So we're good. You didn't have to do that step, but I'm just wondering if you want to. Number 10. I'm going to be here for a while, won't I? Motorboat leaves a harbor. It travels now. Okay, motorboat. So motor. Nav average. Okay, so let's go going. Let's call the other one motor returning. That's how I will set up. So you guys could have used whatever. So going, he was going at traveling at 15 miles an hour. This is my rate. And coming back, he was traveling 10 miles an hour, maybe because of the, of the current. The time traveled was 5 hours. A total of 5 hours. Let me rephrase that. So 5 hours. So if motor going was t hours, the return would be 5 minus t. Multiply. We get 15t. And here we got 50 minus 10t. So what do we know about those two distances? We know the distance going and the distance coming back is the same, right? Same distance. There's variables on both sides. Let's get rid of the minus 10t. So I'll do plus 10t. Plus 10t. This equals 50. And here equals 25t. Divide both sides by 25. And t equals 2. So going took him 2 hours. Returning would be 5 minus 2, which equals 3. So equals to 3. Okay. 12 as part of his what flight training, pilot was required to fly an airport and then return. Okay, so we know. All right. Going, he was at 90 miles an hour. Let me just type in going, and I create a table right away. I need to create T and D. We write return. It's this one. So going was at 90 miles an hour. Okay. And returning was at 20. Definitely was the wind. Find the distance between the two airports if the total flying time was 7 hours. So going, again, let's call that he spent T hours flying, going, and coming back. Well, we know the total time, and I'll write the total time over here, 7. The total time flying, going, and returning, if you sum it up, it's 7. So we don't know specifically how much was each portion, but we know that if we call going, he spent T hours flying to the airport. The return was 7 minus T. Multiply, we get 90T. And here we're going to get 840 minus, what is that? It's 1 time 12, yeah, minus 122. So now we want to set these two equations to each other because the distances are the same. So plus 120t. That goes away. That is, gee, I don't know, 210 it looks like. All right, t. Divide both sides by 210. And t equals, looks like it's 4. So the time flying to the airport was 4. The time coming back would be 7 minus 4, which is 3. That's not what we want. We actually want the distance. So we can go into distance column. Going 90t, right? So here's the going. You find the distance. So it's 90 times 4, which is 360 miles. So that's the distance between both airports. I mean, it doesn't matter if you substitute it here or the return trip because you know they're almost the same distances. But just to check, 840 minus 120 times 4, it's 840 minus 480. 0, 14 minus 8 is 6, 7 minus 4. Look, you get the same. Obviously, this is just confirmation that we are good. 14. Okay, so this is the first man, I guess. And then this is the second man. So the first man, he travels. Okay, he's 5 miles an hour. The second man travels 6 miles an hour, but starts 6 hours later. So the first man has a time of t plus 6 hours. Head advantage. Okay, and the second guy is just t, right, to compensate for the advantage that he has. This is t. What do we want in this question? We want when will the second man overtake the first. Okay, so here we get 5t plus 30. This one we get 60. When they overtake each other, their distances are going to be the same, right? Because you have to catch up. 5t plus 30 equals 6t. Let's get rid of the 5t. Minus 5t. Minus 5t. 30 equals t. And t equals 5. T equals 30. I'm sorry. Is that right? Hang on. No, hang on. Oh, sorry. Following the rate. 8 miles an hour. Okay, so sorry, this is incorrect. This is 8 miles an hour. 8 miles an hour. T, and so this should be 18. My apologies. That makes a difference. When will the second man overtake the first? Okay. So same thing, except that I messed up on the. So minus 5t minus 5t. 3t equals 30. Divide both sides by 3. So in 10 hours. In 10 hours, the second guy will be next to the first guy, and that's when he's going to be overtaking the. Okay. All right, so far not that bad. 16, I just did 14, so 16 is the last one on this page. Long distance runner, starting the course running an average speed of 6, an hour later, second. Okay, so again, same type of question for one. So first guy, let's call this the first runner, then the second runner. So the first runner is a 6 speed, 6 miles an hour. 1 hour later, so a second runner, he goes at 8 miles an hour. How long after second run? Start with the second. Okay, when is he gonna take the first? So this guy, who had the advantage here, an hour later. So this guy's t plus 1. Okay, so let's find d in terms of r and t. So this is 8t. This is 6t plus 6. And when they're equal to each other, right? When one overtakes the other. Minus 6t on both sides. We've got 2t equals 6. Divide both sides by 2. T equals 3. So in 3 hours, the second runner is going to overtake, or at least catch up with him and then pass him. Okay. So as you can tell, this becomes easier and easier as you do them. Okay, so and repetitive even, right? Running at an average of 8, a sprinter ran to the end of the track and then jogged back to the starting point. It took 55 seconds to run and jump. Find the length of the track. Okay, so let's call this going. This coming back, returning. So RTD. Oops. So going there, he traveled at a speed of 8. Coming back, he was jogging because he was probably tired. He returned at 3 miles. Find the distance. Well, the time, the distance to run to the end of the track, the total distance is 55 seconds. So we're gonna call this t, and this is gonna go t minus 55 seconds. Oops, sorry. 55 minus t. So if he took, I don't know, 10 seconds going, returning would be 55 minus those 10 seconds, right? Just an example. So now, this is seconds, by the way. 8 times t is 8t. Here we get 165 minus 3t. The distance, right? They're equal to each other. So 8t equals 165 minus 3t plus 3t to both sides to get rid of that minus 3t. And we get, what is this, 12? 11. 11t equals 165, yuck. And we're going to divide both sides by 11. And t equals, I have no idea, 165 divided by 11 equals 15 seconds. So t going is 15 seconds, which means the coming back portion, t minus 15, 55 minus 15 gives you 40 seconds. So his return was 40 seconds, but we're not interested in that, are we? What are we interested in here? Find the length of the track. So pick a distance, either this one or this one. So going, the distance is 8 times t. We found out what t was, so 8 times 15, which is 120. If you use the returning portion, it's the same thing. Returning 165 minus 3 times 15 165 minus, 3 times 15 is 45, and you get 120. So what do we want here? Find the length of the track. Well, the length is 125 meters. That's the length of the track. 22. A motorboat leaves a harbor and travels at the age toward an island. So 2 to the island, or TD to the island. This guy traveled for 9. And 2, oh, I'm sorry. Oh, so what is it? Cabin cruiser. No idea what that is. So here is a motor. Those of you who have boats, maybe. So here is a motorboat. Here is the cabin cruiser. Okay, the motorboat travels at 9. The cabin cruiser, ooh, much faster, travels at 18. Okay. 2 hours later. So the motorboat had 2 hours advantage head start. Cabin cruiser started 2 hours later, so I'll call that T. This would be 9T plus 18. This would be just 18T. And when the cabin cruiser is next to the motor, it will have traveled the same distance. So 9T equals 18 equals 18T. Get rid of the 9T, minus 9T, minus 9T. 18 equals 9T divided by 9. T equals 2. So in 2 hours, the cabin cruiser will pass. Okay. Learned a new word today. 24, 2 trains, and they're from the same plane traveling in opposite directions. Okay, so you got train A. Okay, so we got train, let's call that train A, train B, going opposite directions, thankfully. So the first train travels at 6 miles per hour more than the rate of the other train. So one train travels at this speed, let's call it, doesn't matter which one, and the other one is R plus 6. Okay, whatever the speed is, plus 6 miles. They are 1 at the end of 4 hours, so they travel for TD. So they travel both for 4 hours. And we know that the distance apart they are after 4 hours, 168 miles. So let's do this. This is 4R. This is 4R plus 6. Right? So their distance after 4 hours is 168 miles. So that distance that train A traveled, right? Remember, one train is going this way and the other train is going this way. So whatever their distance plus the other distance, they're equal to 168. So the moment both trains stop, that distance is 168 miles. Combine like terms, 8R equals, and we're going to throw the 6 to the other side, and we get 162. And divide both sides by 8. And R equals, I don't know, 0.25 or something like that. 162 divided by 8, 20.25. 20.25. So one train was traveling at 20.25 miles per hour, and the other one was traveling at 26.25 miles an hour. Okay. Easy enough. Two cyclists start the same point again, opposite directions, okay? So I guess again, the hardest thing is to understand. Let's call this cyclist A, cyclist B, and setting up your table. So one is twice as fast as the other. So if A is traveling at this speed, R, B is traveling at 2R. That's the speed. In 3 hours, so we know that they cycle for 3 hours, they're going in opposite directions, and they're 72 miles apart. So let's find D. D is 3R, and this one is 6R. Right? So distance of bicycle A plus distance of bicycle B equals 72 miles. 9R equals 72, and 70R equals 8. Divide both sides by 9. equals 8, which means that this guy was traveling at 8 miles an hour, and this guy was traveling times 8 at 16 miles an hour. Okay. At some point, you guys are going to complain how easy this is. But practice does make perfect, right? 30, two small planes. What do you call? Start from the same point and fly again, same type of thing. So let's call that plane A, plane B. RTD. Plane A is 25 miles slower. Okay, so one is R and the other one is R minus 25. Okay, that's how we represent slower. They flew for 2 hours and they're 470 miles apart. So 2R and this one is going to be 2R minus 50. So we set up the equations. 2R plus 2R minus 50 equals, what's the distance? 470. Okay. So 4R minus 50 equals 470. 4R, and let's start cutting corners, guys. 420, and then divide by 4, right? 420 divided by 4, 80 something divided by 4, no. 112.5. 112.5 is the speed of the airplane. So one airplane is 112.5, the other one's 112.5 minus 25. That's going to give us 87.5 miles. Okay. Uh, 32. A family drove, okay, to a resort. Am I pressing? To a resort and later return over the same road at an average speed. Okay, so here we're going to go going. Going, you were traveling 25. Return, you were traveling at 40. Find the distance. So 13 hours was your total drive time. So let's call this T. Going, you spent T hours. Coming back, you spent 13 minus T. The distance traveled was 25T for now, and this one would be 40 times 13, which is, I have no idea, 520 minus 40T. And what do we know? We know that, well, obviously the distance traveled going and coming back is equal to each other. That's how we set up. We're going to add 40 to both sides. We get 65T equals 520. And divide both sides by 65. T equals 520 minus 60 divided by, 520 divided by 65, 8. So the time driving, going, was 8 hours, and coming back, 13 minus 8 equals 5. But that's not the question, is it? Find the distance. So T equals 8, you can either plug it in here or plug it in here. 25 times 8 is 200 miles. And if you do the same thing here, you get 520 minus 40 times 8, which is 320. 520 minus 320, you also get 200. So the distance, you can tell, it's the same, right? So we're good. Motorcycle 34. Okay. Okay, so motorcycle, there's two parts to this trip. Okay, so he drove for a certain part for 45 and then walks. Okay, so the biking part, we'll call this the walking part. Okay. RTD. So I was driven at 40 miles per hour, and then he was walking at 6. The distance from home to work is 25 miles, and the total trip. Okay, so the distance traveled was 25 miles, and the total trip was 2 hours. So I'm gonna put 2 here. So whatever the time biking and the time walking combined, it equals 2 hours. So if he spent t hours biking, the walking portion would be 2 minus t, right? Because that 2 is a total time. And then let's do the distributive property, or 45t over here, and over here is 12 minus 6t. What do I know about the distance? Well, the distance biking and the distance combined, distance biking and the distance walking combined, right? Because it's going to work, plus the distance spent walking equals to 25 miles. So remember, here is 25 miles. We spent some of it biking and some of it walking. That's why their sum is equal to the total, which is 25 miles. Combine like terms, 45 minus 6t is 39t. We're going to do minus 12t on both sides. Okay, you know what? Let me just confirm my numbers. 12 minus, okay, so it looks right. So 39t plus 12 equals 25. 39t minus 12 on both sides, that gives me 13. Divide both sides by 39. T equals 1/3. So, we spent the time, 1/3 of an hour, by the way. 1/3 of an hour. So, I'm going to write the time biking was 1/3 of an hour. And if that's so, 2 minus 1/3 gives me what? 1 2/3 of an hour walking. Okay, is that what I want? How far did he go? Okay, so we're gonna go back. So 1/3 of the time, 1/3 of an hour he spent biking. So multiply 45 times 1/3, and that's gonna give us 15. So he spent 15 miles, what do you call, on the bike, and then obviously he walked for the last 10. Ugh, long walk. 36. 36. Okay, so we know the distance of the trip. So RTD. It's the first column. Again, same type of problem. So let's call that leg A, part A of the trip, and leg B of the trip. Okay. So car traveled 55 some part of the trip, and then reduce the speed to 40. The total trip was 2.5 hours. So if for leg A he spent t hours driving at 55 miles, so leg B would be 2.5 minus t. Okay, so that's all the information I have. 55t. 40 times 2.5 is 100. And we get 100 minus 40t. So what do we know about the distance? The leg A plus leg B equals, what is it? Equals to 130 miles. Okay, so 55t plus 100 minus 40t equals 130 miles, because that's the total trip. So combine like terms, 15t plus 100 equals 130, minus 100 on both sides. 15t equals 30, t equals 2. So he spent 2 hours on driving for 55 miles, and then 40 spent half an hour. 0.5 of an hour is half an hour at 40 miles an hour, probably because that was not the highway or something. So, but that's not the question. For how long did he drive? Oh, yeah, that is a question. For how long did the car travel 40 miles an hour? Only for 0.5 of an hour. So that was correct. 38. Is that the last question? Yay. An executive drove for an average an airport with a helicopter. Executive board a helicopter. Okay, so car, helicopter. I'll just call it heli. 2 portions of this trip. Right? He's going wherever to. corporate office or something. So RTD. With the car, he was driving at 40 miles an hour. Then he took a helicopter, was at 60 miles an hour. The entire trip took 3 hours. So if the car traveled for this many hours at t, right? We're going to call time driven at 40 miles an hour t, which means the helicopter was 3 minus t. 3 hours minus whatever time I spent in the car. The distance, 40t. This one is 180 minus 60t. The distance, so yeah. So the distance traveled by car, which is represented by 40t, plus the distance traveled by helicopter, which is represented by 180 minus 60t, equals the total distance of 150 miles. So now we have negative 20t equals, let's throw, we got, I'm just doing step by step. Negative 20t plus 180 equals 150. Subtract 180 from each side. We get negative 20t equals, what is this? Negative 30. Divide both sides by negative 20. And t equals 3 over 2, or 1.5 hours. Okay, so find the distance from the airport to the corporate office. Okay, so actually we're probably better off leaving as an improper fraction, 3 over 2. Okay. So if the total time is 3 hours, it actually says that he spent, we can just leave it as 1.5, right? 1.5 on the car, and again, 3 over 2 is the same thing as 1.5. And 3 minus 3 over 2 is also 1.5. So 180 minus 60 times 3 over 2. 180 minus, you can simplify that, right? 30 times 3 is 90. And the portion traveled by helicopter is 90 miles. Right. So hopefully I did most of them correct. Good. And that was your assignment.